Morning, everyone. This is Chen Liu presentation. Today, my subtopic of 3D technology is about 3D face recognition. There are nearly 7.6 billion people living on this earth where we live. Everyone's face is composed of several areas such as eyes, nose, mouth, and so on. The general positional relationship between them is also fixed, and the size of each face is not much different. However, they have formed many complicated patterns, and we have to admit that there are no two identical faces in this world. However, even for twins with extremely similar faces, their families can usually distinguish them very easily. So, what are the features that distinguish so many different faces? Can we design an automatic machine with the same face recognition ability as human beings? Can the face recognition ability of this automatic machine surpass that of human beings? Let's take these questions and walk into the topic of facial recognition together. So, what is face recognition? Face recognition is a kind of biometric identification technology based on the face feature information of people. But why we need face recognition? Generally speaking, human identification methods are divided into three classes. The first one to use characteristic items such as ID card, student card, and so on. The second one is to use some special knowledge, passwords, secret codes, and so on. The third one is to use human biological characteristics like human face, fingerprint, and the voice, and so on. The first two feature recognition methods belong to traditional identification technologies, which are very convenient and fast. But the shortcomings of these are poor security and easy to steal. Therefore, human biological characteristics have become the most ideal identification feature due to their stability and unique. In this presentation, I will introduce three parts. The first one is to make an introduction of face recognition. The second is to focus on the development of 3D face recognition. The finally make some discussion on the advantages and disadvantages of these different methods. In the end, summarize the current status and existing problems of 3D face recognitions. Now, let's turn to the history of face recognitions. The research on face recognition can be traced back to the 2016s and 2017s. The development process of face recognition technology can be divided into three stages. The first stage is semi-mechanical recognition method. The second one is based on the human-computer interactive recognition method. And the third stage is the stage where we are now. The machine can automatically perform face recognition and a judgment. For the first stage, the representative paper of this period is computer-generated animation of faces. You can see in the first image. In this paper, the researchers realized the method of using a green scale image model of the human face to recognize the human face. But such a system cannot complete the face recognition process by itself because it is mainly based on a large number of manual operations. For the second stage, researchers can use some simple representation methods to represent high-level features of face pictures. For example, in the second image from one paper, geometric feature parameters are used to represent the frontal image of a human face. But it still requires a high degree of participation of researchers. For the last stage, automatic face recognition stage, artificial neural network has been widely used. The recognition process can be truly automated. Now, I would like to ask everyone to think of a question. If one person puts on makeup, will it affect the performance of face recognition, or if she is in a very particularly bad light scene? So the answer will be reviewed in the next slide. Traditional face recognition methods are based on the theory of 2D image analysis to represent, analyze, extract features, and classify and recognize faces. However, face recognition methods based on 2D image are easily affected by imaging conditions, such as illumination, posture, and expressions. Compared with 2D data, 3D data contains the spatial information of the human face, which is inherent information of the human face, and is very robust to changes in external conditions. The collected 3D shape data of the shape does not change with the changes of illumination and view, and the makeup has a great influence on 2D image, but not very obvious on 3D data. And the 3D face recognition is more secure. 2D traditional face recognition only compares simple pictures, and the safety factor is very low. So we can see the compare from this table. Although the face itself has 3D attributes, the use of 3D face data for face recognition is more advantage. 3D face data can be estimated from 2D color images, or can be directly obtained using 3D imaging equipment. The reliability of face depth data estimated from 2D color image is not very high, and it's easily affected by factors such as illumination, posture, expression. Therefore, the more commonly used method in 3D face recognition is to directly use 3D imaging equipment to obtain 3D shape data. 3D imaging equipment mainly include high precision 3D scanner and low precision RGBD cameras. These equipment have been introduced in Timia and Rand's presentation in the first presentation and the second presentation. So for now, 3D face recognition method can be divided into 3 methods: based on color image, based on high quality 3D scanning data, and based on low quality RGBD image. Let's introduce them by part. For the first one, this type of image usually reconstructs a 3D face model from a color image, and then use a 3D model to perform face recognition. The main methods include use 3D face model parameters for face recognition, and use 3D face model to synthesize new face image for face recognition. Using 3D model parameter for face recognition. In this paper, you can see from the picture, proposes a face recognition method combining 2D and 3D. First, reconstruct the 3D face model from the 2D images. Then, the similarity scores are calculated separately according to the color image and the 3D face model. Specifically, the similarity score of the color image is obtained by the method of deep neural network, and the similarity score of 3D method model is obtained by the ICP method. Finally, ICP method is iterative closest point method. Finally, the two scores are weighted to obtain the recognition result. Next, to use this model to synthesize new face image. This paper in this image propose a fast 3D face modeling method based on a single image using the reconstructed 3D model to render pictures with different status as a training set. And the researchers also use this model to correct the poses and expressions in the face image. By the steps of rotating the model, adjusting the parameters, it is corrected to an expressionless on the corrected face image for recognition. And what is the advantage and disadvantage of this method? It can be seen that 3D face recognition method based on 2D image usually requires 3D face modeling. The main advantage of this type is that it can effectively reduce the influence of other factors. The main disadvantage is that 3D face modeling is relatively time-consuming, and the accuracy of modeling have a greater impact on the recognition results. And because the modeling results of different image of the same person will be different. So let's come to the next method. At present, most of 3D face recognition methods are based on high-quality 3D scanning data. Different types of facial features can be extracted from the 3D scanning data. According to the types of face features, the existing method can be divided into 3 classes: global feature, local feature, and deep feature. Method based on global feature usually recognize the 3D face as a whole. In this picture, from one paper, it selects a set of curves on the face surface as a representation of the face, so that the 3D face recognition is transferred into the matching problem of 2D curves, which greatly reduce the difficulty of 3D face matching. The author uses a radial curve based on the tips of the nose to represent the entire face surface. This method first located the tips of the nose, and then uses a plane passing through the tips of the nose to segment the surface of the face at certain angles. The intersection line of the face surface is the radial curve. Due to the problem of occlusion, some radial curves are discontinuous or too short. This curve will be discarded, and the remaining curves are used for face recognitions. Compared to global features, local features are more robust to face expression change and occlusion. Local features are usually extracted on the basis of key points or local surveys. The Mass LBP paper proposed the LBP feature based on a 3D grid for a certain triangular face in the grid. Use it as the center face, and find the 3 related faces based on the 3 edges of the face. On the basis, find a circle around the certain plane, and repeat the process to find multiple rings composed of triangular planes. Sample a fixed number of triangular faces on the ring. Compare the curvature of the center face and the upper part of the ring, and then divide the face into a set of regions according to the predefined key points, and count the histogram of LBP in each regions to get features of face recognitions. At present, researchers have gradually applied deep learning to 3D face recognition. The features extracted by deep learning method are usually called deep features. In this paper, seen from this picture, first locate the 3 key points of the eye and the tips of the nose on the 3D point cloud. Perform posture correction based on the 3 key points, and then convert the 3D point cloud into a depth map, and extract 4 sub-images with certain overlap from the depth map. Input each sub-image into a deep learning network and do the face recognition. For now, let's introduce the last method. The last method is based on low-quality RGB image. In recent years, RGB cameras such as Connect have gradually been widely used. Compared with the high precision 3D scanning equipment, RGBD cameras have low cost and can quickly collect color maps and depth maps, 2D and 3D. But the quality of the depth maps obtained is very low. It is difficult to obtain better face recognition accuracy use deep maps. Therefore, it is usually necessary to use both color map and deep map for recognitions. This paper, you can see from this image, this paper extends the 2D face recognition based on deep learning to RGBD face recognition and extract features and fusion features from the color map and deep map through 2 neural network models. In order to make up for the insufficient training data for depth map, this method first use the color map to train a neural network and then perform transfer learning on the small scale deep map data. So we have learned 3 main methods of 3D face recognition at present. For now, 2D recognition method based on color image have made great progress, but face recognition still face challenges under the changes of illumination, posture, and expression. An important reason is that 2D face image lose deep information. Although reconstructing a 3D face model from 2D image can restore the shape of a 3D face, the reliability of the depth data obtained in this way is not very high, and the modeling process is usually time-consuming. Therefore, 3D face recognition method based on color map estimation on face depth is currently not very active. And the more commonly used method is to directly obtain face depth map data through hardware devices. Face recognition method based on high-quality 3D scanning data cannot be applied on a large scale in the real scene due to factors such as equipment cost and collection methods. The face recognition method based on low-cost RGBD camera can be used in more occasions. There are still some existing problems in 3D face recognition, such as the problem of 3D database, the problem of fusion, how to combine 2D and 3D data, and the problem to solve the effect of the changes in facial expressions. Thank you for listening. And any questions?